Alright, welcome back to Physics Math. So right now we're going to be doing a review of trigonometry, and this is going to be trigonometry part 1. So I'm splitting up trigonometry into probably about 4 videos. We'll see how much we cover in each section, but there's a lot to go over for trigonometry, so I wanted to give it a fair amount of time to do an extensive review. But we're going to start off discussing how to convert from radians to degrees and then degrees back to radians. When we use trigonometric functions, a lot of times we're going to be using radians instead of degrees, so the ability to make these conversions is going to become important in calculus. So that's why I want to spend a little bit of time just going through the conversion. So when we convert from radians to degrees, what we are doing is essentially saying, for a given angle, we're saying that this angle in degrees is equivalent to essentially what percent of the total circumference. So let's say this is about 45 degrees. Now, the definition of circumference is 2 pi times the radius of a circle. So that's the circumference that's going the entire way around the circle. If we only go halfway around the circle, now let me use another color. So halfway around the circle, we get an angle of 180 degrees. So with this definition of 2 pi r for the circumference, and halfway around the circle is 180 degrees, or the whole way around is 360 degrees, we get a circumference to angle ratio of 2 pi r divided by 360 degrees. And since r is arbitrary, when we're thinking of angles, r can really go away. And we say this is 2 pi radians. So this is really the conversion factor between radians and degrees. 2 pi radians is equivalent to 360 degrees. And the reason I wrote 180 here is because this conversion factor is typically written as pi radians. Actually, that's normally abbreviated rad, or RAD, divided by 180 degrees. So again, pi radians is half the circumference, so you're going from here over to here, and you're transversing 180 degrees. So this is really the ratio that's most often used, but it comes from this idea of comparing the circumference to the total degrees in a circle. So let's put this to the test a little bit and make a couple conversions. So I'm going to make a table of degrees, conversion factor, I'll just write conversion, and radians. So when we convert between degrees and radians, it's important to get the conversion factor correct. So we're going from degrees to radians. So for degrees to cancel out, we're going to have to put the 180 in the denominator. So put 180 in the denominator, put pi up top. And now I'm going to use a different color. We're going to convert from degrees to radians by multiplying by the conversion. So let's start with 90 degrees. So 90 degrees times pi divided by 180 is going to equal pi over 2 radians. And that's because 90 goes into 180 2 times, and it's in the denominator. So what if we have 45 degrees? 45 degrees times pi divided by 180 is going to equal pi over 4 radians. Now let's try something a little different. Let's do a value greater than 360, and we'll see this conversion factor still works. even if you go multiple times around the circle, you can still convert from degrees to radians. So let's say 720 degrees. 720 degrees times pi divided by 180 is going to equal 4 pi radians. And similarly, if you have negative angles, you can still make the conversion. So we'll say negative, I'll just keep it easy, 180 degrees. Negative 180 degrees times pi over 180 is going to equal negative pi radians. Now let's convert back. Let's see. So this time we're going to convert from radians to degrees. And because of this, we need to use a different conversion factor. We need to use the reciprocal. So this time we're going to put 180 on top and pi in the denominator. And that's so that the radians cancels and we're left with degrees. So now let's say we have, we'll say 3 over 2 pi radians. So the pi's will cancel and we'll be left with 3 halves times 180 degrees. 3 halves times 180 degrees is going to be 270 degrees. And we can do other values. Let's try negative 1/4 pi. Again, negative 1/4, just multiply by the conversion. And we're going to be left with negative 45 degrees. So if this doesn't come too naturally, I would try to do a couple practice problems by yourself. Just pick a couple values, just try to do the conversions. You can use a calculator like Wolfram Alpha or really any calculator that has the ability to convert from degrees to radians, and just test yourself and your results to make sure you're doing it right. But when we move forward in mathematics and calculus, we really need to get used to thinking of angles in terms of radians as opposed to degrees. It's going to become a lot more common. And the next thing I'm going to talk about is what I like to think of as the basis of trigonometry. It's really the, well, it's a topic and a concept that's used all the time in trigonometry. And this topic can be represented by one word, and that is, you may have heard it before, Sohcahtoa. Sohcahtoa is an acronym that helps you memorize the definitions of sine, cosine, and tangent. And this is where we're going to go next in this course. We're going to go in detail into the definitions of sine, cosine, and tangent and how to use it. So these trigonometric functions are useful when you're trying to analyze a right triangle. So previously, when we have two sides of a right triangle, we can find the third side using the Pythagorean theorem. So if this side was side A, this is side B, this is side C, we know that a squared plus b squared equals c squared from geometry. Where this comes in is, let's say you're still trying to find a side and you know one of the sides, but you don't know this. You don't know the other side, so you don't know B or you don't know A. But you know the angle. Using trigonometry, we can find this angle by using the ratios of the other two sides that we know. So I'm going to start with this first part of Sohcahtoa. So, what this stands for is sine of theta is equal to the opposite over the hypotenuse. So it's the opposite side over the hypotenuse. Hypotenuse is the longest side of the triangle. Opposite is referring to the side that's opposite to the angle. So in this case, it would be opposite A over C. So if we know the angle and we know one side, we can find the other side, or if we know both sides, we can find the angle using the inverse of this function. So that's so. Ka and toa are very similar. Where cosine, oh, I guess ka, I'll use different colors. We'll use red for ka, S for, or green for so. I'll just do a little color there. So for ka, the C is going to stand for cosine of theta, and the ratio this time is going to be the adjacent side over the hypotenuse. Adjacent over hypotenuse. Actually, I'm going to put these back, so A, B. Actually, no, we're going to start calling these the actual names. So hypotenuse, this is the adjacent side, and this is the opposite side. Again, adjacent and opposite are in terms of the angle theta. So cosine of theta is the length of the adjacent side, gotta make that hypotenuse. The length of the adjacent side divided by the length of the hypotenuse. And similar to sine, if you know two of these values, you can find the third. And then last but not least, we have toa. And toa stands for tangent of theta, which equals opposite over adjacent. So let's do a couple examples of these. Let's say we have a right triangle. Oops. A right triangle, and this angle is, let's say it's pi over 3 radians. It's pi over 3 radians, and let's say the value of the hypotenuse is 10 feet. And the value of the opposite side is 7 feet. And let's say, well, actually, now let's say we don't know the value of the opposite side, but we want to find it. So to figure out which one of these we need to use, we just need to look at what pieces we have and what we're looking for. So we have the angle, we have the hypotenuse, and we're looking for opposite. The only one here that has opposite and hypotenuse is sine, so we're going to be using sine of pi over 3 is equal to opposite over adjacent. So opposite over adjacent, 10 feet. And now to solve for opposite, we're going to multiply both sides by 10 feet. 10 feet is going to cancel on this side, and we're going to be left with 10 sine of pi over 3 feet is equal to the length of the opposite side. And if we plug this into a calculator, we'd find a value for that. I'm not going to plug things into a calculator in this course. We're just going to set it up to a point where we could type it in and find a value. If you want to do that on your own, then go ahead. But right now we're just trying to get the theoretical, the theoretical side to these calculations. Because as long as we know how to do these problems, plugging it into a calculator or some type of mathematical system is pretty easy, and there's not really much practice needed for that. So let's do another example. This time, let's say we don't know the angle, and we know that this side is a value of 3, and let's do the adjacent this time. So the adjacent is 5. No, sorry, we'll make this nice. So the adjacent is a value of 4, the opposite is a value of 3, and we're looking for the hypotenuse, which actually we'll call that h. In word problems, they might just assign that x, but you can just know that that is the hypotenuse. Put all these markers down. So here we have the adjacent side. We have the, that can be, yeah. We're looking for the angle. So we have the adjacent side, the opposite side, and theta. The only one up here that has both adjacent and opposite is TOA, so we're going to use tangent. So tangent of theta is going to equal opposite divided by adjacent, so 3/4. And to solve for theta, we need to use the inverse tangent function. And this is written as tangent to the -1. And I'll have to move this over. Tangent to the -1 of 3/4. And when you have inverse tangent of tangent, these cancel out, and you're left with theta. So the angle theta is tangent to the -1 of 3/4, or inverse tangent of 3/4. And this is also called arctangent of 3/4. Arctangent and inverse tangent are the same thing. It just depends on the book or the system that you're using, but these are equivalent inverse functions. And this is another thing we could type into a calculator and get an answer for, which I'm not going to do that in this course, but again, if you'd like to do that, feel free to go ahead and type that into a calculator. And one point of note is when you do type things into a calculator, oftentimes the default is in terms of radians. So you might get a weird value for an angle. It might look really small. If it doesn't make sense, convert from radians to degrees or vice versa. Some things have the option to change the base value of the angle, but just be conscious of which system you're using. Otherwise you might get a weird looking answer. And we'll do one more example before we stop this video for the day. So let's say, we'll do a word problem. Let's say you have a tower of height 100 meters. Let's see. And let's say you want to figure out how far away you are from the tower. So you don't know this distance. We'll call it x. And you're trying to figure out how far away you are without actually measuring this value. You can look at the angle from the ground to the top of the tower, and you can find this distance. So this would be an example of a kind of a weird practical example. I don't know why you wouldn't just measure this, but let's just say for some reason you can't. Maybe there's like a chasm in between you and the tower, but you're looking to figure out how far away this is. And you measure an angle of 30 degrees. So how would we solve for the distance between you and the tower? So if we look at Sohcahtoa, we can see that we have an angle. We have a height, which is opposite of the angle, and we're looking for the distance, which is adjacent to the angle. And it looks like we would use TOA again, because we have opposite, we're looking for adjacent, and we have the angle. So let's plug this in. So we know tangent of theta is equal to opposite divided by adjacent. And we know that theta is equal to 30 degrees. So we can solve for our missing value of x. Let's see, this is meters. So to solve for x, we multiply both sides by x. And we're left with x tangent of 30 equals 100 meters. And we still don't have x by itself, so we have to divide both sides by tangent of 30 or multiply by 1 over tangent of 30. I find it easier to just divide. Tangent of 30. And on the left-hand side, tangent 30 will cancel out, and we're left with just x. I'll rewrite that. So we're left with x equals 100 meters divided by tangent of 30 degrees. And if we plug this into a calculator, we would get an actual value for the distance from the tower to the observer, or to you. So that is the answer to that word problem. All right, I think I'm going to stop here, and we'll continue with part 2 next time.